This is the fourth event in the SIDDHI webinar series. SIDDHI is an acronym for Self-Learned India, Discussions and Dialogues for Humane Innovations. The SIDDHI webinar series is being organized to commemorate the 150th anniversary of Mahatma Gandhi. The themes broadly will be technology for self-reliance, socially relevant technologies, technology and rural development. And this is probably the first webinar in the series that is technical. So we are literally coming into the, the Spark and Vajra, mood of the webinar series. The title is Emerging Trends in Smart Manufacturing, Opportunities and Challenges. We have a fantastic panel today. The moderator is Dr. U. Chandrasekhar of Addwize Wipro 3D. He is a program director Addwize at Wipro 3D, Bangalore, wherein he is actually in charge of competency building programs in additive engineering and facilitating enterprise level adoption of metal AM technologies. He has a huge experience in DRDO for about 28 years and has led 2 national level technology development projects. And the panelists will be Professor Svetan Ratchev from University of Nottingham, Professor Kulwant Pawar of University of Nottingham, then Professor R.P. Sundaraj from IIT Madras, Dr. Amit from IIT Madras. Without much ado, I hand over the session to Dr. U. Chandrasekhar, who is the moderator for today's event. Thank you.
Yeah, good evening, and once again, welcome to all the panelists as well as the audience for this program with a topical focus on smart manufacturing. I indeed studied the subjects of manufacturing and design way back in '88 in IIT Madras. For me to connect through this program with the fraternity of IIT Madras is a great, very pleasure-giving moment. Fundamentally, my primary comments on the topic is this particular program couldn't have been at more appropriate time, because we have been witnessing massive disruptions to the supply chain cycles. And we have seen how the small scale industries on one side and the large multinational companies have been adapting their supply chains using several innovative
Dr. Chandrasekhar, we lost you.
I think probably, Amit, the next panelist probably can take over, no? Presentation.
Sure. So, so we'll start with the Professor Svetan then. So I'll share my screen and I'll control the slide deck. So can you see that?
Yes, sir.
Okay.
I think you need to select it.
Sure. So just.
Yeah.
Hello. Sure, no problem. So we're starting the slide deck. Okay. Yes.
Let me know when to start.
Yes, you can start now. Yes.
Right. Okay. So first of all, let me introduce myself. My name is Svetan Ratchev, and I'm director of the Institute for Advanced Manufacturing at the University of Nottingham. And also, I have the honor to be visiting professor at the Indian Institute of Technology in Madras. What I'm going to talk about is some of the challenges and the opportunities that manufacturing is experiencing and really witnessing in the digital age, in the time of massive transformation caused by digital technologies. Next, please. Next slide.
Yeah.
So the first thing that we need to look at is what are the key trends towards future smart factories? And there is a well-defined need to transform current capital-intensive lines into smart, agile, reconfigurable, and adaptable manufacturing systems and services. And what are the key requirements behind this? First of all, there is a very, very clear need to increase productivity and reduce cost of manufacturing in order for manufacturers to remain competitive in what is a very competitive global market. There is also a need to respond better to market fluctuations. And we're living in some unprecedented times with COVID-19. And this is a particularly valid requirement today in terms of ability to rapidly respond, repurpose, redefine, even relocate manufacturing facilities in order to respond to market demands and market spikes. In order to manage these disruptive events, we're looking more and more towards artificial intelligence, autonomous ability to respond, and based on that, deliver resilience for manufacturing systems. And also we're looking at moving towards manufacturing as a service driven by different economic and societal drives. And last but not least, there is a massive increase in terms of complexity of manufacturing systems, for which finding optimum decisions requires both human and machine intelligence. Next, please.
So I have changed it.
So what I'm going to do is give three different quick examples of different trends in digital manufacturing today. The first one is smart manufacturing systems. And we define this as open platforms that can adapt, that have context awareness, and that are cost effective in terms of production. And we achieve these based on distributed intelligence and ability to continuously adapt. And if you look at the figure, what we have defined here is a system that can configure, monitor its performance, evaluate, and then adapt its configuration, its behavior, and its capability in response to product evolution, to changes in processes, and also to changes in external environments. And all this is driven by a number of critical research questions, like what is the optimum architecture and structure of such system? How can we deliver decision-making in different hierarchical structures? How can we achieve resilience, robustness, adaptability of the system in the face of disruption from different sources? And also, last but not least, how is the human operator integrated in that environment, and how can we achieve smart hybrid decision-making in that context? Next, please. So on the next slide, you will see an example of that, how we contextualize smart manufacturing systems. So this is a demonstrator that we developed at University of Nottingham, which is focused on aircraft assembly of aerostructures. And what we have here is all devices are connected in a real-time network. We use embedded intelligence with decentralized control, and also information sharing through context awareness environment, where each device is aware of other devices in the system. And we also use plug and place or plug and produce approach to plugging in and plugging out different processes and different equipment elements. All this allows us to do is have continuous automatic performance monitoring and also predictive maintenance in the system. It allows us much higher traceability of how different processes behave and how different products have all the data and all the information associated with them, we can collect it. We call it the product and process DNA. And that allows us to deliver a qualitative type new manufacturing system. We have tested and validated this with some of the latest ideas of the factory of the future for leading aerospace manufacturers like Airbus, BAE Systems, GKN, Spirit Aerospace, and others. Next. The second example that I want to demonstrate is another direction of development called cloud manufacturing. And here what we do is leverage some of the cloud technologies from computer science into manufacturing that allows us to create a cloud of manufacturing resources from different facilities, from different distributed factories, put it together, and then allow the customer to define its requirements. And then the manufacturing cloud defines the best configuration of manufacturing capabilities, including logistics. Next, please. We have worked on the cloud concept for about 7-8 years, jointly with Professor Pawar. And what we have developed is a prototype environment, which is based on cloud manufacturing server, which you can see on the screen now, which allows the customer to define their product requirements. It allows different manufacturers to participate by offering their capabilities, and there is a cloud management environment. Behind this, there is a very extensive data model, but also we have applied this in different limited demonstration and test beds. And you can see on the right side of the slide an example of local cloud of SMEs, which we developed, and also an example of factory cloud, which we implemented in one of the Siemens factories here in the UK in a place called Congleton. Next slide, please. The third example, or the third trend, which we find very important, is the adoption of digital technologies by small and medium-sized enterprises. And as we all know, they operate in a much more constrained environment. So the challenges here is to find low-cost solutions and then implement them where they're really required, and by this, lowering the barriers of adoption by SMEs. So this is a joint program that we have called Digital Manufacturing on a Shoestring, which is jointly delivered with University of Cambridge and Nottingham. And our focus is really on increasing the digital capabilities of SMEs by using low-cost, easily accessible, off-the-shelf components. Next, please. The next slide basically shows how we implemented that. We have a set of building blocks, which is different low-cost solutions that provide computing, sensing, cloud capability, and different interfaces. We have a system which builds them together into solutions, and then we deliver this as an integrated solution to SMEs as a very low-cost solution. And some examples that we have implemented include part tracking, job status monitoring, process monitoring, and others. And next slide, please. I want to conclude with this by really putting several key points about digital manufacturing and the trends today. The first one is that digital technologies offer new manufacturing solutions in a rapidly changing and dynamic industrial landscape. To deliver the perceived advantages, digital technologies, and this is very important, need to be applied and implemented with clear technical and business focus. And also the third factor here is the engineers and the operators that we need to train that will be equipped with technical knowledge and interdisciplinary skill sets for the future. And I'll finish with this. Thank you very much for your attention.
Yeah, thank you, Professor Svetan, for setting the context and bringing in the important functionalities of digital manufacturing. May I now request Professor R.K. Amit from the Department of Management Studies of IIT Madras to do the talk.
Right. So thank you, Dr. Chandrasekhar. Yes. So I think I'll continue from where Dr. Svetan left, but I may go slightly more into the history of manufacturing. So I've given the title Canvas of Smart Manufacturing. What is the role of technology? So I sit in the management department and work mainly in the operations management area and at the interface of manufacturing and supply chain management. So I think when we talk about manufacturing, so we always look for what are the goals which we should have for manufacturing. So some of you may be aware of the faster, cheaper, better, and diverse, right? So it means that the productivity should be high. I can produce as fast as possible. It should be not expensive. It should be cost effective. The quality should be high, and I should produce as much variety as possible. But unfortunately, these goals may be conflicting. So in fact, I'll show you the subsequent slides where you would realize that if you really want to produce faster, the diversity you have to bear with. It means that you produce less variety, but maybe the productivity is higher. So this means that the flexibility is not free. In fact, this was coming from George Stigler in a very seminal paper way back in 1939. And this becomes more like the paradigm for manufacturing. In fact, the largest beautiful is something which comes as a wisdom for manufacturing during the early phases of industrial revolution. And two core ideas, the economies of scale. You keep on scaling up, the cost will keep on coming down. And this becomes the rule of thumb. The learning curves becomes the second. So both are related, the economies of scale and learning curve. And the wisdom which comes is, as I mentioned earlier, that variety inhibits speed. So what we observe is that the different manufacturing paradigms, if you actually see this particular slide, you can actually realize that before 1913, if you just take 1930, maybe the era of starting of mass production system, the volume per variant was low, but the variety was high, right? So when we go to the mass, the variety diminishes and you would see more volume. Then post 1980s, we come into the era of mass customization, and now we are actually talking about mass personalization. So the main point here is, can technology assist us to actually achieve both the volume and the variety at the same time? And I think this is something which comes as part of industry paradigms. So it's not just about the manufacturing is changing, the whole ecosystem is changing. So when we talk about Industry 4.0, this is the era of digital convergence. And what we are actually observing is a lot of visibility in supply chains. It's not about machine is communicating to machine. The products are also communicating to machine. I think that is something which will actually enable the smart manufacturing. So when we talk about technology, I think Professor Svetan already had talked about some of them at the implementation level. So in fact, this list is not exhaustive. There would be so many other things which may be happening at the same time. But what is critical here is these technologies may exist independent of each other maybe for some time. But what we are seeing now, what we are observing is the convergence of these technologies. So I put machine intelligence. In fact, 3D printing is just a subset. We are now talking about multidimensional printing. IIoT is coming up. In fact, it's already there. So, but I look at the convergence. We are observing digital supply chains, platforms. Professor Svetan already talked about the cloud manufacturing, and I put blockchains along with it. So these technologies, when they converge together, they are substantially impacting manufacturing. So this is something which people from operations management should be aware, that there is a trade-off between high volume and variety, right? So I have already talked about that. And this is called as the product process matrix. And you can actually see that different production processes, how they are actually mapped to different type of products. Now, this is something which is taken for granted for a pretty long time. Now, what we are actually observing, maybe the technology of additive manufacturing would actually allow us to achieve maybe more variety along with the high volume. I think that is where something which was technically infeasible or assumed to be technically infeasible may be possible, maybe with the technology of additive manufacturing. So this is one where the technology can impact the smart manufacturing. I'll keep on going. I think when we talk about manufacturing, we have to look at the larger ecosystem. We have to match the business with the technology. And one thing which comes again as one of the objective is you want to match supply with demand. But the environment in which we have to do it is highly variable and uncertain. And we need buffers to match the supply with demand with a lot of variability and uncertainty. And that is where I think the whole idea of machine intelligence comes into the picture, whether we can actually use machine intelligence to know more about the environment, right? So in fact, if I just put this example, think of the COVID situation. So supply chains were not ready. There was no signal which was coming with how the supply chains will get impacted. So we talk about prognosis. So maybe we actually need prognosis in the context of supply chains, and that is where the machine intelligence will become the core idea. Now, I'll just extend this argument. With modern supply chains and with different type of manufacturing, in fact, more complex manufacturing, the supply chains are becoming more and more complex. The products are also with high variety, more complexity, more technology. In fact, supply chains are becoming highly complex. I give you an example. When tsunami came in Japan in 2011, Intel tried to map their supply chain, and they could not go beyond tier 3. So beyond that, the visibility in the supply chain itself was not there, right? In fact, when you look at supply chains for strategic materials like cobalt and lithium, the supply chains are highly opaque. And I think that is where the technology of IoT platforms, blockchains, they actually combine with the technology of machine intelligence and additive manufacturing. And that would actually bring more democratized manufacturing. I think we are talking about Mahatma Gandhi, and Mahatma Gandhi was someone who was a big supporter of decentralization. I think that is something which we have to witness in manufacturing also. Right. So with this, I'll stop. Thank you.
Professor Amit, thank you very much for that brief presentation on the implications of volume and variety, and also the importance of mass customization and personalization in the context of evolving models. Yes. May I request non-speaking panelists to switch off the video mode and remain in the only audio mode, because only then the panelist, whoever is speaking, can be seen in the screen. It's my pleasure now to invite Professor Kulwant Pawar. He is the Director for the Center for Concurrent Enterprises at University of Nottingham. May I request Kulwant Pawar to address the gathering.
Okay, thank you very much, Dr. Chandrasekhar. And I think my colleagues, Professor Ratchev and Professor Amit, have set the whole scenario extremely well. What I'm going to focus on, I'm an engineer by profession, but I work in the business school. And Professor Ratchev and myself, we have worked together on different projects over the last 20 years or so. And I'm going to talk about readiness assessment. My previous speakers have talked about exactly manufacturing and smart manufacturing, digital manufacturing. From my point of view, how ready are we in different aspects of manufacturing? And this is where I'm going to focus on. And if you come to the next slide, please. If you look at manufacturing, and Professor Ratchev mentioned already about cloud manufacturing, and we've been working along in this area here. and saying manufacturing has a huge variety of dimensions. There's actually making the goods or the service associated with it, or actual operations associated with it, or talking about the business side or the strategy side or the legal side. So when we're talking about manufacturing, we want to know how ready are we in different dimensions of manufacturing. This is based on a paper we wrote, Professor Ratchev and myself, along with a student, and it was published last year and presented at a conference in France, IEEE conference in France last year. And next, please. Then you take the actual manufacturing, and in the different dimensions of manufacturing, whether this is the resources available or the capability aspects, or the automation, or the other machine-to-machine interaction, or optimization, or the flexibility, the way we make. We want to assess different dimensions, how we as an organization, how ready are we? Then, of course, looking at readiness, it depends. Are we at a mature level? On the right-hand side of the diagram, you'll see you can be a beginner, or you can be a learner, or you can be more experienced, or you can be a master. You just take a scenario at the moment, or analogy of COVID-19. If you look around the world, how different countries have managed this. Some people are more advanced compared to others. Similarly, in manufacturing, if you wish to look at or adopt or deploy different smart technologies to do our manufacturing, we need to make sure we are ready to adopt those. Next, please. And what we have also been doing, we have been working in parallel with the PA Consulting as a part of the cloud project. And last year, we conducted a survey from a supply chain point of view in Europe and in the US. And we got more than 100 respondents to this. And I'm going to share some of the key findings from this survey. And we found something like 69% of supply chain leaders felt their vision was basic or developing. In other words, yes, they wish to do something in digital supply chain, but their vision is pretty basic at the moment. And secondly, 30% felt the value which they get from adopting these technologies, they don't know what's the value of this. Thirdly, capabilities, which was also mentioned by Professor Ratchev, the capability to transform from where we are now towards that we are delivering what we want to deliver in the next, say, 1 year or 2 years or 5 years' time, is very limited. That there's a problem with it. We haven't got the right skills or the capabilities to do this. Next, please. Other thing we found in terms of now, what is driving this shift now towards digital supply chains or capabilities? And why? People are saying, as Professor Ratchev mentioned already, main reason is cost. We want to reduce our cost. Secondly, 59% said they wish to access these different technologies because things are developing very rapidly and they don't want to be left behind. And third reason they gave was buyer or customer behavior and preferences. Customer is always changing, the buyer behavior is changing, so therefore companies don't wish to be left behind. And then looking at the second question, investment levels. How much investment, we asked them, would you be making over the next, say, 12 months or so? 9% said no investment at all. 35% said 1 to 2% of revenue. And 47% said we don't know. And then the third question, which I mentioned on the slide, who's driving this shift within the organization? 41% said leadership and 25% business units. And 18% said ad hoc, experimental. They're trying out these technologies and to see how it works. Next, please. Then we ask the question, what factors are limiting your organization's ability to capture value from existing digital opportunities? And as you can see on the graph, 39% felt they are busy with other things. They're not able to focus on what we want to do with these technologies. Another interesting point, the second issue which was mentioned, ambiguity. There's a lot of hype about what it says, blockchains or 3D printing or different technologies. They're not sure about these technologies. How will they work within their own environment? And thirdly, which is again very interesting from my point of view, methodology. They're not sure. How will they deploy these? What's the stepwise approach they will take in order to adopt? So there's no clear methodology. How will they do it? Next, please. And again, why do organizations struggle? And into which factors are limiting your organization, the digital supply chain agenda at the executive level? And is saying internal skills and capabilities. This again came very strongly. 43% said we haven't got the capabilities. Yes, we have the desire to do something, but we don't have the internal capabilities. Another interesting point came from this study was legacy systems. That is always there. You never have a clean sheet of paper. You can say, yes, I'm going to start something new. You always something, your systems, your processes, your people as well, they're there already. And this came along to the next point, which is about culture. And organizational culture perhaps is not conducive to adopt or deploy some of these technologies. That also comes down to the skill levels as well as the organizational culture. They are not receptive to these kind of changes. Next, please. This really leads me to the last slide, transformation. You may have the vision, but the reality is totally different. What we promise is fantastic. This is what we're going to do. But in practice, this is something I came across from LinkedIn, and it was a nice slide. I thought, this is interesting. Then you look at the top line, this is what we're promising. Just like the politicians, they promise the earth when they want your vote. When it comes to delivery, and reality is totally different. And I think you see in always, when you want to adopt something, performance drops. That always happens in organization. Here they'll call it valley of despair. And only when we get accustomed to using these kind of technologies, approaches, and then our performance level goes up. And that is when I think you're trying to hopefully catch up or close a gap with what was promised. And then, of course, new fad or new technology comes in and your performance dips again. I will stop at this point and take any questions later on.
Yeah. Thank you, Professor Kulwant for encapsulating some of the factors that are impeding the growth of digital supply chain. And though the observations were given in the context of Europe and other countries, I'm sure many of them are relevant to the Indian context too. We will take some questions relevant to that in the Q&A session. It's a final presentation in the panel discussion today by Professor R.P. Sundarraj. He's from the Department of Management Studies from IIT Madras.
Thank you, Chandrasekhar, for the introduction. My name is Sundarraj. I've been a professor in IIT Madras in the Department of Management Studies for about 10 years. And prior to that, I was at the University of Waterloo and also served some positions in the Middle East and also in the US. My expertise is in the combination of both information systems and operations management and supply chain management. and more specifically in the creation of information systems and also in the adoption of information systems. What we've seen so far in the talk, if you might, is a question where both Professor Ratchev and Professor Amit have laid out the technological foundations, one giving what is currently operating today, Professor Ratchev talking about what is currently operating, what is the cutting edge of things operating today, and Professor Amit gave a very good contextualization of where things came from, to mass personalization, and also what are some challenges in really realizing,
Professor Sundaraj, sorry to interrupt you. Your voice is very low, please. Can you move the?
Hear me now?
Yeah, your voice is low.
Can you hear me now?
Yeah.
All right. So the point is that the technological introduction was a good background as to what is possible. But the question, as Professor Cole already raised, is whether somebody is ready for it, and that is a very critical question. And we got a very good overview survey of the things that were actually relevant. Things such as are people relevant, and so is technology really relevant for today? And what factors can impede them? Some of them being are they ready or not? Okay. So in this particular talk, next slide, please. In this particular segment of the talk, what we will do is to drill this down a little bit. We'll talk about what is adoption per se, and we'll also talk about a case study in a different domain altogether, which we have done in the recent past, and see to what extent we can glean some lessons to developing something called readiness index for advanced manufacturing, both in UK and in India. So let us see how that works, how that process might unfold. Okay. So when we look at adoption itself, the adoption can be at different levels. Okay. So for example, talking about the COVID situation, there were no RT-PCR kits some time ago, but now it is available quite a plenty, quite a bit better than what it was. So there is some level of industry adoption that is taking place, or retail adoption that has happened as well, compared to maybe 4, 5, 6 months ago. Okay. From that point, you get to organizational adoption, and then organization can adopt a certain technology, and then comes individual adoption. So the question becomes, how are these related? And I alluded to that a little bit here. What are the factors that involve? Okay, that is one point. And the last point is, how do we know, whether organization is ready or not? So those are the 3 things that I'll touch upon in this particular, 5, 6 minutes left. Next slide, please. Okay, this is the 2 famous models. Will contextualize what has happened already, in terms of what Professor Pawar has outlined. If you look at the left chart, that is the famous Gartner hype cycle that somewhat addresses some of the industry adoption, if you will, in the wider spectrum of things that take place. Okay, so what could be considered a cutting edge technology today might become something that is there for all of us to take. Okay, so it's very easy for us to see things like internet adoption and so forth, which was very new in 1995, is almost taken for granted. People are born into that sort of technology. So it is not a big deal for us to expect something like that to happen, and so forth. So a readiness for a technology like that is going to be much different than a technology that's upcoming in front. So we really need to understand at the industry context, how things are happening. And so that's what you see in the Gartner hype chart. And the next thing on the right-hand side of the particular slide, you also see a very famous diffusion of innovations model as to when and how the process takes place. The initial innovators are the initial adopters, initially. Then there are early adopters, and there are majority of adopters, late majority, and laggards. So this is how, these are the various stages by which these things take place. And this also tells you, the percentage of people that keep on adopting things as time progresses. So as we go into a sufficiently long time, which is what I would say is for the internet case today, almost there's 100% adoption that is taking place and so forth. So with time, all the people will catch up. And that's exactly the point that Professor Pawar had out. So if you were to look at any of the SMEs or any of the person with an employee within SME adopting it, that's a totally different question. And unless that question is answered, the adoption of the technology really doesn't get and seep into the entire thing. Okay. So on the right-hand side of this particular slide, you would see, the factors that are more relevant at a personal level. For example, is it really useful to me? Is it giving me any result that is actually doing? For example, Zoom technology, is it really useful? And can I get this seminar done quite easily or not? So those are things that are relevant to me, as an individual user. Okay. So both those factors need to be considered in order to look at whether adoption is taking place at all at the three levels, of industry, organization, and individual. Next slide, please. There are some common assessment methods that are there. The famous of them is, I think Professor Pawar also put up something similar to this, is a HIMSS model for healthcare analytics, or the CMMI model for maturity, and they are classifying things into 5 maturity levels and so forth. The thing that differentiates readiness from such maturity models is twofold. Number one, maturity happens after post-adoption. So we want to say, hey, you want to go on this Gartner cycle of adopting more and more, or becoming more and more into this technology. How far am I into the complete adoption of a particular technology, complete realization of that technology? That's a completely different question than assessing whether I'm ready for it today or not. That's a completely different question. Okay. And the second thing is, the maturity models often have levels of maturity, and it doesn't offer any insight into what I need to do, a prescriptive insight on what I need to do in order to make this happen. Okay. So I think that is where and those factors that I showed you in the previous slide are so crucial in factoring in, how ready are we in doing the assessment. Okay. So let's see next slide, please. So let us see how that works, with a healthcare example. The most important thing that we considered here was a literature review of what are the factors that are there. And those factors I already showed you 2 slides ago for other examples of technology. So maybe for manufacturing or for healthcare or for some other domain, there may be different sets of factors that may be applicable. Professor Pawar had also indicated something like that. But that is not sufficient for us to garner or really gather all the factors that are there. And the next thing is, we went through a number of case studies which are qualitative. Any technology that is up and coming and really to start off requires inputs of a qualitative nature that we need to find out as to what is really impeding somebody from adopting or not. Are there additional factors that we've not considered in the literature, because this is a new technology clearly, and therefore factors in the literature might be deficient in terms of what really impedes the adoption or makes the adoption much faster. Okay, so case studies are there, but as we go along, okay, we're also, the key point that I would like to note here in terms of process of developing a readiness index, we go back and figure out, can we make modifications to literature? So all these 2 processes, these 2 steps, make us come up with a functional set of requirements. And again, once we get that, we validate that, and then we go to the case studies to figure out whether the functional requirements that we have in place is really making sense to me or not. Okay. Next slide, please. Okay, after we do all that, we come up with a bunch of factors, and this shows you both the input and output of everything. On the top side, you have the input as to what factors are important for readiness. On the other 3 things, you have an interplay of models as to how these factors interact with each other to say which factor is important, which factor is not important. There are some interactions that have to be factored in. And the final, on the radar chart that you see in the bottom half of the screen, you see which factor, on which factor are we really doing well, on which factor we're not doing well. So what you see on the top right and the bottom left are models that are required to assess the interfactor importance to figure out how these factors really come into play. Okay, next slide. Okay, so last slide. This is going to be my last slide. So lessons learned and conclusions from this from this case study. Both from the system on the left, you have the lessons, on the right, you have the conclusions. Okay. On the left, in the top part, we have the system's development features. Okay, so we talked about multiple factors, multiple levels of importance that I alluded to in and how these factors relate to each other. Interdependence among these factors is crucial, to implement the technology. On the development of the process for a readiness assessment index, which we think is important that we glean from the healthcare side to the manufacturing side, is consider multiple stakeholders in this thing, consider multiple case studies, and adopt an iterative process for this to happen. So to conclude, we have seen a variety of readiness assessment, methodologies, and we've seen a case study for that, and the lessons learned in terms of both the features and the process. And the key question now is whether some things that we have learned out of this case study really do hold good for other things as well.
Thank you. Thank you, Professor Sundaraj, for delineating the concept of the readiness of the adoption and giving the context with reference to the healthcare sector. So I request all the panelists to get into the video mode. Can I give a couple of seconds for all of you to get into the video mode? Professor Kulant Pava? Okay. So we have approximately 12 minutes for closing the panel discussion. So maybe I require about 4 to 5 minutes for summing it up. So we can take some of the questions for about 6 to 7 minutes. I would go back to Professor Svetan. You mentioned about an extremely interesting concept called autonomous response. And you also made a mention about decentralized control. And you gave one very powerful example corresponding to the context in aero structure development. But conventionally, the strategic sectors have got a lot of control. They are very regimented. So how do you see the evolution of these kind of models where you are talking about distributed decision making?
Yeah, there is obviously a tension between regulated environments, and in all key sectors, we have highly regulated industries. And then autonomous control, giving the control to the system to make decisions is always a challenging element to it. So what we have done in that area was to develop something called bounded autonomy, where we use autonomous control to keep the performance of the system within defined boundaries, which allows basically for continuous optimization of the performance of the system. And we have recently developed several applications like this, where, for instance, one of them is capturing data from different machine tools in one very large automotive company, then looking at the best performing of these machines in terms of different performance indicators, and then adjusting the parameters of the other machines continuously to match that performance. And by this, we have increased the efficiency of the whole system with something incredible, like almost kind of 12%. And that was a very small project that one of our researchers did. So this one example, how we manage autonomous element with highly regulated industries.
Thank you. Thank you. Thank you. So the concept of bounded autonomy is very, very important in this regulated. Yeah. Professor Amit, you just talked about the ramifications of volume and variety. In recent times, we have seen the producers becoming consumers. Some people refer to as presumption. Do you see more and more examples of presumption, coming to the forefront, which is going to provide immense, possibilities of variety?
Right. So I think Professor Svetan also talked about manufacturing as a service. So I think down the line, I think we should look more towards commoditization of manufacturing. So because when I actually attend some of the industry talks, when I interact with them, one issue which comes is how we actually scale up for, say, SMEs. And at that point, I think this issue comes in, can I just provide something more as a service? So I'm pretty sure that whatever Professor Pawar talked, whatever Professor RPS talked about, a lot of anxiety among the SMEs, like how we actually can use some of these technologies. So I think down the line, we should look for how we scale it up using more of providing manufacturing as a platform. So some initiatives are there. I think in that direction, suddenly so someone can be a producer there and someone can be a consumer there.
Sure. Thanks. Professor Pawar, you made a presentation with a lot of interesting factors, which have got some universal, you can say, levels of acceptance. One important factor which struck me was many places, the digital supply chains are affected by lack of skills. And that is one factor which is really creating a humongous obstacle to the uptake of this DSC model. Do you see any difference between what is prevalent in terms of lack of skills between India vis-a-vis other countries?
I think this is an interesting point. In fact, when both Professor Ratchev and myself were in IIT Mumbai, IIT Chennai, and I think one thing during the workshop we found, we had 80 participants and quite a few of our industry. We conducted a workshop, and large proportion of the participants felt the skill levels was a big challenge. And this, I think, subsequently, I think also was apparent in our discussions with the number of organizations we went to visit. And I think from my experience, having worked with a number of organizations and institutions in India, is a huge challenge, certainly within India, as it is in Europe. I think so. I think, yes, maybe the severity of challenges may be different in different areas, but the challenges are equally valid in different countries.
Okay, thank you. Thanks, Professor Pawar. Professor Sundaraj, you made a brief reference to the world famous hype curve. And in case of most of the new technologies, we have seen a valley of death and a plateau, and again a resurgence. So do you envisage a similar kind of a trend for the new models of the smart manufacturing, both in the context of developing economies as well as the developed economies?
There is a saying, old wine in new bottles, I think.
Yeah.
And that is actually happening in some ways in computing. It has happened already in computing, in terms of cloud computing. You might recall in the days, when we used to timeshare machines on IBM mainframe and so forth, that sort of thing. And then we used to own, for example, machines ourselves, and now it has come back to, back to the cloud, where we are actually timesharing and pay-as-we-go models. Okay. So a resurgence like that is likely to also happen, but at this point we are doing mass personalization. Okay, the only thing that is different about what Amit talked about in mass personalization is the word mass. Okay, now we can do it in mass. Okay, before it was always personalized. You would go to a corner shop and they would do it for you in the way you want it. Okay. So it's quite possible some of these can re-emerge, but it's hard to predict. But at least looking at the computing model, it looks like there are some similarities. Not all of it would hold, but some of it might transfer over in the next resurgence, the next cycle of resurgence.
Thanks. Since you talked about, thanks, Professor Sundaraj. I'll go back to Professor Amit. You made a specific mention about machine intelligence being used for estimating the buffers. So do you see that kind of model emerging in the near term in Indian context, where machine intelligence can be objectively used for assessment of the buffers in the context of small scale industries?
I think we are still doing it. It's already there at the implementation level. I think a lot of companies who have come up, at least I know in Research Park,
yeah,
whose domain is actually mainly to actually use AI for manufacturing. Okay. So when I say buffers, I think my idea was to look at the overall manufacturing environment. So there would be a lot of uncertainty, a lot of variability in the environment. And I think that is where the AI part would actually become helpful. So I think we are already seeing that thing. Maybe the scaled up part, I'm still not very sure. But we already have seen at the technology demonstration level, we have some examples. So some companies, in fact, in Research Park, in fact, last week only I was discussing with someone. So it's already there. So only issue is how we scale it up, how we actually can take it to the SMEs where they actually can use it?
Thank you. So there's quite many more questions, but respecting the time frame, I would get into the conclusion part of the session. To start with, Professor Svetan presented many innovative concepts, including the concept of hybrid decision making, distributed intelligence. Particularly the point of interest for me, because of my own interest in the small scale industries, is you talked about the low cost digital architecture for SMEs and the concept of building blocks for digital solutions. I think this is going to be a very important facet for implementation. In a country like India, where tens of thousands of small scale industries are not able to adopt these models, where they are very cost sensitive to new technologies, this concept of building block and low cost solutions will be fantastic to rely upon. Professor R.K. Amit, opened his talk with a very interesting and simple topic of faster, cheaper, and better and diversified solutions. I think these are some of the things which are going to be perennially relevant, and digital supply chains are going to be no exceptions to that. I just want to give one example in the context of India. When the swabs for RT-PCR tests were not available, we have seen on one side a very large multi-billion-dollar companies like Reliance Polymers and DuPont coming to the forefront. At the same time, we have seen the emergence of small companies in the suburbs of Bombay and Bangalore using digital light processing units and making these swabs in few hundreds and few thousands. So making the better products, making the diversified products, and making them cheaper is going to be extremely relevant for the supply chains in the near future. And it's a very democratic field because small companies can compete with the big companies. So in that way, the importance of smart supply chain systems is going to be important. Professor Power's presentation was teeming with a lot of interesting aspects. I have so many questions corresponding to the vision of the drivers. You mentioned very interesting and relevant topic. 30% of the people are not able to demystify the value associated with this. That's the reason why they are not able to implement. I would like to say, in a context of India, it could be more than 30%, maybe 70%, because somebody has to sensitize them to the possibilities. Somebody has to evangelize and be the champions of the change. And I have seen the larger the organization in terms of size and operations, the greater is the resistance to change. So when you want to introduce a new concept, there'll be so many naysayers. And your concept of creating a sensitivity to all these factors that impede is very important. And the survey that you conducted is universally applicable. And Professor Sundarraj gave a very succinct description of the adoption readiness. And some of the lessons which are learned from the healthcare sector are universally applicable. I think those of you who have seen how the PPEs, how surgical masks and mechanical respirators and emergency breathing assistive devices have been developed, if you really try to find out what is motivation behind them, on one side there is a social innovation cost, but on other side, if you see the basic denominator among all these companies is about the ability to use the new technologies and create a synergistic model with the supply chain. So this is a very distinct factor we have seen. Whether it's a small company and big company, they're able to create a symbiotic relation between technologies and supply chain models. And I have seen personally how many places which were intensely affected, places like Hyderabad and Bangalore, happen to get important things like face shields from remote locations like Jaipur, Gurgaon, even in COVID dominating situations because of this ability of the companies to integrate technology with the supply chains. So overall, the four sparkling speakers gave extremely diverse insights. I would like to congratulate all of them on providing multivariate context to the digital supply chains and on the models of smart manufacturing, which are evolving, which will continue to evolve. And I would like to thank once again IIT Madras for conceptualizing this particular webinar and making it happen. Thank you so much.
Thank you, Professor. Now I ask Professor Karthik Raman to give the vote of thanks.
So, sorry.
So, good evening, everyone. Karthik. I'm from the Office of Global Engagement at IIT Madras and also at the Department of Biotechnology. And I'd really like to thank all of you who made it today. It was a wonderful session with very, very interesting speakers and who spoke about various aspects of smart manufacturing, particularly in the context of the present challenging situation. And I would like to thank our moderator as well as our speakers for the time and sharing their views and the nice discussion that followed. And I also take this opportunity to announce a series of very interesting webinars we have scheduled for next week. Can we have the slides up?
Yes, Professor.
Yeah. So, it's, both on the occasion of Health and Environment Week, as also most importantly, Gandhiji's 150th birth anniversary. So we have a very interesting series of webinars. I request you all to tune in. So first we have universal health coverage in India, where are we and the way forward. So this is very contextual again. And the moderator is Professor V.R. Muralidharan from HSS. And we have three very interesting panelists, Dr. Rajani, Professor Dilip, and Dr. Girija, whom I think many of us would already know. Next. Next slide, Rudra. Yeah. So, and then we have, technology for self-reliance, again, very aligned with the theme of SIDDHI. And we have Professor Sujata as one of the panelists, and then Swastik, who's the CEO of NeoMotion Assistive Solutions, and Vaidyanathan. And these panelists will talk to us about how technology can improve the life of people with disability. And many of us have already seen very interesting contributions from Professor Sujata on this count and the others as well. And the moderator is VR Feroz. Next slide. And on 3rd of October, we have again a very interesting thing, particularly in the context of COVID, the spread of infectious disease, antimicrobial resistance, and so on, where we have techniques for improved wastewater treatment for reuse. And the speaker is Professor George from UC Davis, and our own Professor Indumati from Civil Engineering. And the last in the series we have on October 4th, Sustainable Water and Waste Management in Villages. Again, we have both speakers are from IIT Madras, so Professor Liji Philip and Professor B.S. Murthy. So it promises to be a very interesting series of and very relevant webinars in the context of the current situation, health and environment, both of which have been threatened by the current pandemic. And I look forward to seeing most of you there, and please pass the word around. And we will also have a new SIDDHI website up shortly, and this should stimulate further discussions, because we do not want the SIDDHI webinar to be over with this 1 hour tuning in and discussing with the panelists. I'm sure you have a lot of questions. I hope we'll have an extended discussion on the website. There'll be features to support that on the website, and I hope we'll have a lot of participation from all of you. Thank you all, and have a wonderful weekend.
Thank you. Thank you.
So thanks, Siddhi, I think, for organizing this. So thanks a lot. It was a wonderful experience. So thanks, Sudarshan. I think it was all your effort. So thanks a lot. And I thank Dr. Chandrasekhar, Professor Pawar, Professor Svetan, Professor RPS, right, to agree and be part of this panel discussion. So thanks a lot.
It's a team effort. Thanks to all of you. Yeah. Bye.
Thank you.
Night.